right, good morning. Welcome back to pre-calculus. So we are talking about systems of equations, nonlinear equations. So when I'm looking at this, they don't ask us to graph this. When I'm looking at this system, okay, we've got something that looks kind of like a or something that looks like an ellipse because both x and y are squared is equal to something. We can divide by 13 and get an ellipse here. I hope you guys can see that. And then we have an x squared minus a y squared. So we have a left, well, actually equals -1. So when I divide by -67, it's going to change the sign. So we're going to get a negative something x squared plus something y squared. So it's going to be hyperbola. It's going to be up and down. Okay, so this is a quick sketch. Let's see here. We're going to be an up and down hyperbola. Okay, and I'm not graphing this very carefully. And there's going to be some kind of an ellipse in the middle here. So it's possible we can get 4 equations or 4 solutions. It's possible we can get, if I make this actually hit, that'll be 2 equations. Okay, both of them are centered at 0, 0. So it could be like moved over a little bit. So it's possible we could have some kind of a system that looks like this. Okay, where we get 2 solutions like that. That's a possibility, but since they're all at 0, 0, we're looking at something that looks like this or something that looks like this. And it is possible that we get no solutions. We could have our little hyperbola here, and then somewhere in our null space in the middle, we have an ellipse in the middle. Okay, that's not touching anything. Okay, that's a possibility. So this is a rare time when we get a 4x squared. Okay, let's make sure we write down the problem correctly this time. 4x squared plus y squared equals 13. And then we have 5x squared minus 8y squared equals -67. Okay, now here's what you have to notice on this one. If I multiply this top equation by 8, okay, what's going to happen when I add them together is that these y squared terms are going to drop out. That's kind of what we want. Okay, so we have 8 times 4 is 32, x squared plus 8y squared equals 13 by 8. That's going to be 80 plus 24. So that's going to be 104. I'm going to double check that just to make sure because my mental math is not good anymore. Okay, so we're going to have 8 times 13, and I don't want to reshoot this. Okay, so clear 8 times 13. So there's nothing wrong with checking, but yes, 104. Okay, and we have 5x squared minus 8y squared equals -67. You don't really have to be that good at mental math to get through most of your life. I recommend it. It does help. It is helpful. Okay, I would go through and keep a mental tally of what I spent on groceries all the time. Okay, add these two together. 32 plus 5 is 37 x squared. 8 minus 8, 0. And then we have 104 minus 67. It's going to be what? 33, 36. So again, I'm going to double check this thing. 104 minus 67. Okay. We got 37. What do you know? 37. Go figure. What a coincidence that they would. It's not going to be guaranteed that it's going to do this. Okay, it's not guaranteed. Okay, it's just textbook problems tend to work out like this, but that's not a guarantee. So we end up with x squared equals 1. I think we can confidently say that x is equal to plus or minus 1. Square root principle on both sides here. Okay, square root principle. That's why I'm getting my plus or minus 1. Okay, so once I have my x equals plus or minus 1, we've got to plug them back into the original equation. Okay, actually, in this case, both of my equations hit for x squared. So I could, because there's no linear term. If there was a linear term and there was just an x in there, I would need to test both plus and minus 1. But since x squared is equal to 1 regardless, okay, plus or minus, what we can do is replace the x squared with 1 and solve it from there. Okay, pick either equation that you would like. I'm going to pick the top equation. So we're going to have 4x squared plus y squared equals 60 or equals 13. 4 times 1 plus y squared equals 13. Okay, so we go ahead and subtract both sides. We have y squared is equal to 9, y is equal to plus or minus 3. Here's where the fun begins. We have to get every permutation that's possible. So x equals positive 1 or negative 1. So we have 1 at y equals 3. We have negative 1, we have 1, negative 3. We have negative 1, 3, negative 1, negative 3. These are the 4 pairs of solutions that we're going to have, okay? Because I didn't go through and test out for each and every possibility for x, we just tested x squared. When I solve this thing, I have to remember to get both possibilities for x's and both possibilities for my y's. Okay, so we have 1, negative 1, 3, negative 3. So we're going to have 4 solutions. So the first iteration I have is like this one. That's what we're going to have. Okay, so we're going to have solution set, and then we're just going to have this one. Solution set is the finite set, and we just have 4 different pairs of things to put in here. Happens more often than we'd want to admit. Okay, so comma, this is going to be a pain. Okay, comma, boom, comma, and boom. Okay, so we're going to have, and I'm just going to get all the different permutations that we have here. Okay, that's just all there is to it. So we have 1, 3. Okay, so we have 1, I use the tab button. I hope, negative 1, 3. Okay, 1, negative 3. Does it matter which way you put this in? Not to me. Probably not to Alex either, because there's no real good way of saying this. Just make sure we got them all in there. Okay, 1, 3, negative 1, 3, negative 1, negative 3. Okay, any way you want to track that is just fine. Okay, we'll go ahead and check. Okay, hooray, we got our green flag and we can move on. So thank you for coming along, and I will see you on the next video.